A stack is an abstract data type commonly used in most programming languages. It is named stack as it behaves like a real world stack. For example, cards and arranging the plates, right? A real world stack allows operation at one end only. For example, we can place or remove a card or plate from the top of the stack only. Like that, the stack allows all the operation only at one end. At any given time, we can only access the top element of the stack. The main feature of stack is LIFO concept. The LIFO concept is nothing but it means last in first out, right? So here the element which is placed or that is inserted or added in a last is accessed first. In stack terminology, insertion operation is called a push and removal operation is called a pop operation. The next one is stack representation. How we can represent the element in a stack. So here we can using the two operation push and pop. Push is nothing but we can insert the element into the stack, and pop operation is we can remove any one element from the stack, right? A stack can be implemented by means of array, structures, pointers and linked list. Then the stack can either be a fixed size one or it may have the sense of dynamic resizing. Here we are going to implement stack using array, which makes it is fixed size stack implementation, right? So the next one is basic operations of stack. The stack operation may involve initializing the stack, using it and then deinitializing it. Apart from these basic stuff, a stack is used for the following two primary operations. One is push, another one is pop operation. Pushing means storing an element on the stack. Pop means accessing an element from the stack, right? So when the data is pushed onto the stack, to use the stack efficiently, we need to check the status of stack as well. For the same purpose, the following functionality is added to the stack. So the following functionalities are peek function, stack is full function, and stack is empty, is full as well as is empty function. Then the peek function is nothing but get the top data element of the stack without removing it. That is the concept of peek method. Then is full method is nothing but check if stack is full. If empty is nothing but check if stack is empty, right? So at all time we maintain a pointer to the last pushed data onto the stack, as this pointer always represents the top of the stack, hence named top. The top pointer provides top value of the stack without actually removing it, right? So this is the basic operations of stack. So first we should learn about the procedure to support a stack function. First is the peek function. The algorithm for peek method is begin procedure peek, return stack of top. So return stack of top means we can insert the element into the particular stack, then end procedure. Then implementing of peek method function, the C programming language example is integer peek, return stack top, right? So we can apply this line in a C programming. The next one is if the stack is full. Suppose if the stack is full, we can using the algorithm is begin procedure is full. If top equal to maximum size, return true, otherwise return false, end of the statement or end if. So the C programming we are applying the top of the stack is boolean if full is full, if top is equal to maximum size, return true or return false. The next one is empty operation. The stack empty operation is nothing but implementation of empty function in a C programming language is slightly different, right? We can initialize top at -1. So we can initialize the empty operation the value is -1 as the index in our array start from 0. The index value start from 0. So we check if the top is below 0 or -1 to determine if the stack is empty, right? So the example is begin procedure is empty if top less than 1, then return true, otherwise it return false, end of the statement, right? The next one is push operation. The process of putting a new data element onto stack is known as a push operation. Push operation involves the series of steps. First step is checks if the stack is full, right? Check if the stack is full. The next one is if the stack is full, procedures and error and exit. Sorry, if the stack is full, it produces an error and exit. Third one is if the stack is not full, increment top to point next empty space. The next one is add data element to the stack location where the top is pointing. Then returning success, right? So this is the concept of stack. So here the example, we can take up the stack, we can insert the element A, B, C, D and the top of the stack is E, right? In here the top of the stack is E. So if the linked list is used to implement the stack, then in step 3 we need to allocate the space dynamically. So algorithm for push operation is a simple algorithm for push operation can be derived as follows. Begin procedure push stack of data. Suppose if the stack is full, it will return the null value end if, right? Or top is equal to top plus 1. We can increment the value. Then stack top is equal to, we can insert the data end procedure. Then implementation of this algorithm in C, it is see the following code. Void push into data. Suppose if the stack is full, we can increment the data, that is top is equal to top plus 1. Then stack of top is equal to data. Then else print could not insert data, the stack is full, right? The next one is pop operation. Accessing the content while removing it from the stack is also known as a pop operation. In an array implementation of pop operation, the data element is not actually removed. Instead of top is decremented to a lower position in the stack to point to the next value. But in linked list implementation, pop operation is actually remove data element and deallocates the memory space. So the following steps to be followed by the pop operation is, first one is check whether the stack is empty. Then if the stack is empty, it produces an error and exit. Then if the stack is not empty, access the data element at which top is pointing. Then decreasing the value of top by 1 and returning the success. So here also the example, we have insert the element into the particular stack A, B, C, D, E. Here the top of the stack is E, right? Then we can apply the pop-up concept. We can insert the last element into the pop option. So we can remove the element E, right? So we can remove the element E means automatically the next element will be moved to the top position. So we can pop up E, the next top element is D, right? So this is the concept of pop operation. So here the algorithm for pop operation, a simple algorithm for pop operation can be derived as begin procedure pop up stack. If stack is empty, return null or empty if. Then data stack of top is equal to top minus 1, return data end procedure. The simple example for C program, integer pop integer data, if is empty, data is equal to stack of top. Top is equal to top minus 1, return data, else print could not retrieve the data, the stack is empty. Thank you.